Greetings everyone, myself Aryan from Developers and Coders Club, NIT Agartala, and today we're going to discuss the question make pair which was asked in CP Titan 3.0. So if you read the question mentioned that there is a classroom and teacher want to arrange the students such that the no two same genders are adjacent to each other, and your goal is to find the minimum number of swaps you need to do such that the no two same gender are adjacent to each other, and if no possible case or arrangement exists, then you have to print the minus one, right? So let me bring to the let you to the whiteboard so for the better understanding. Sorry, yeah. So yeah, let's see the cases one by one, okay, for the better understanding. So yeah, so yeah, so let's see the case one, right? It will be the case one. The case one will what will the possible arrangement will be there if the number of boys and the number of girls are differed by more than one. What I am saying, suppose the arrangement is boy, boy, and girl, 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 girl. There are four girls and two boys, or else if there is a one boy and three girls, then what are the possible arrangements will be there in such things where the number of difference between number of boys and girls is greater than 1. And when I am saying the difference, then I want you to take it the mod of the number of boys minus number of girls, like absolute difference, like without sign. So what will the number cases exist in this case? Well, let's try together, right? If we take the case this one, because I can explain better from the small example, right? Like B and 3Gs, right? Then what are the possible arrangement? If we put the boy here, the girl here, the girl here, and then there is no case, then we have to put the girl here, right? Or else we somehow take the boy here, then also it will be not possible. If we take the boy here, then it will be also not possible, right? So we can see that what conclusion we can make, that if the number of boys minus number of girls if greater than 1, sorry, the mod of these two things, sorry, mod of these two things, if greater than 1, then no solution will exist, right? No solution will be exist, and we have to print minus 1, right? We have to give the minus 1 as the answer, right? This will be the condition, this will be the answer when the number of boys and number of girls are differed by more than once, right? Okay, now let's see the another condition, right? When number of boys and number of girls are differed by only once, right? Let's see that case for. Let's say there is a boy, boy, girl, 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 or we can say there will be a case when boy, 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 and girl, 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 girl. What you can see, what are the possible arrangements will be there in this case, like the no two same gender are adjacent to each other? What things comes in your mind? Obviously the first intuition says that okay, if we have more number of girls, then we put the girls in the starting indexes and then put the boys, so that the all will be get settled. What I'm saying, let's see this example, the boy, boy, girl, 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 right? So if somehow we take this boy here, right, and take this boy here, then it will be the only possible arrangement where the no two same genders are adjacent to each other. See, boy, girl, girl, boy, girl. Is there any other possible arrangement, right? There is no other possible arrangement. Like it will be the only one condition where the boys and the girls will be adjacent to each other and no two same gender will be sitting next to each other, right? So it is the only condition. Okay, so what condition left now? The only one condition left, right? What will be the possible arrangements when the number of boys and number of girls will be equal. Suppose boy, boy, girl, girl. What will be the possible answers when the boys and girls will be equal? Well, the one possible condition will be we can put the girl, boy, girl, boy, right? This will be one of the condition. Or the another condition will be if we put the boys first, the boy, girl, right? These two will be the only possible arrangements that are possible. Okay, so this was all about the possible arrangements and what will be the cases. Now the question doesn't ask all the possible arrangement. The question asks for the minimum number of swaps we have to do such that the no two genders are adjacent to each other. Let's look at that first. Okay, let me bring you back to the case number 2, because in case number 1 we know if the number of boys and number of girls are greater than 1, then the solution will be -1, because there are no possible case arrangement, and if no possible arrangement exists, then the solution will be obviously -1, right? Now look at we just look at the case number 2, right? Let me bring, okay, case 2. What we have seen, the number of boys and number of girls are differed by 1. The boy, 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 and the girl, girl. So what was the possible arrangement in this case? The possible arrangement was boy, girl, and then boy. Okay, so for making this arrangement, what we have to do? We have to make the swaps, right? We can swap these two things and make them like this: boy, boy, girl, boy, girl, right? Here we again have these two persons adjacent same gender, then we can make the swap here in the boy, girl, boy, boy, girl, boy, and we have to make the swap here also, girl, boy, right? This will be the final arrangement, right? One swap here and one swap here, right? One swap here and one swap here. We have to do total we have to do the certain number of swaps. Okay, so what observation you can derive from here? We can see that in the case when the number of boys and number of girls are differed by 1, then the number of gender who are in majority means is greater than the small, if the number of girls are greater than number of boys, then the girls will be in majority, and if the number of boys will be greater than number of girls, then the boys will be in majority. Okay, the whoever the gender is in majority will have to occupy the even indices. What I have mean to say, see here, 0, 1, 2, 3, 4, right? The boys has to be on even indices like 0, 2 and 4, right? And the rest will be fall automatically, right? So this was all for the case number 2. What we can do in case number 2, we can store the indices of the boys or the gender which is in the majority, here it is in boys, in the array or a vector, right? And we know in the correct arrangement the boy should be in the odd even positions, right? Even indices. So we have to just calculate the difference, that how much swaps we need to do such that the boys reach to the correct indices. Let me do a dry run. Suppose we have boy, boy, and girl, boy, girl, right? So what will here the possible arrangement will be? The boy, the boy, the boy, and girl, girl. This will be the final arrangement. Okay, so here 0, 1, 2, 3, 4, and here will be it 0, 1, 2, 3, 4. Okay, so what we will do, we will store the indices of the boys or the person who is in majority in the vector as I mentioned. So let's just store this. It will be the 0, 1, and 3, right? And in our final answer here, in our final answer, what we can witness, the new positions are the 0, 2, and 4. So let's just put this also 0, 2, and 4. So how many number of swaps we have done to take the boy from their old locations to the new locations? We can easily calculate this by calculating the difference in the position, right? The new position versus the old position. What other changes had come, right? So here will be what? It will be 0 plus 1 plus 1, right? So in total we have to make the 2 swaps only. right? So I hope this case is clear, and I suggest everyone to just make a dry run also, so better for better understanding, right? And similarly, in if the girls will be majority, then we have to do this thing only, right? Now let me take you the last case. Then the number of boys and number of girls will be in uh, in same majority. The boys will be number of boys will be equal to number of girls. Let's see that case. Right. So the the ultimate condition, the ultimate arrangement will be something look like this: the boy, 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 girl, 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 right? Or it will look like something like this: girl, 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 and boy, boy, boy. So our goal is to know which of among these two arrangement, which arrangement will give us the minimum number of swap such that the no two adjacent gender are same, right? This was our goal, to make the arrangement such that no two adjacent genders are same, right? So let's just see this. So let's just consider this as the case 3A and case 3B, right? So in case 3A, let me look, yeah, boy, girl, boy, girl, boy, and girl, yeah, okay. So what is this? This is our one of the final arrangement, like one of the possible arrangements which we get. Oh, okay. So let me highlight with this blue, okay. And our old arrangement was something like, let me see, yeah. So our old arrangement was something like boy, 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 and girl, girl. Okay. So in old arrangement, what are the positions of boy? And in new arrangement, it is something like this. So if you notice this arrangement, this final answer, what you can see, the boys are in even indices, right? In the case 3A, and there will be another cases when the boys are will be in odd condition, right? If the boys are in the odd condition, then the position of girls will be the even condition, right? It's just like you can see there with a 0, 1, 2, 3, 4, and 5. So the positions of girls are even indices, right? So we will see this case in case 2B. Okay, let's just can understand case 1A. So in this case, the boys are in the even indices. So we just have to know the how many swaps we have to make the this possible arrangement from this possible arrangement, right? So what we can do, we can use the same concept, right? We store the indices of boys and the girls in the separate arrays, right? The old indices, and we will calculate the number of swaps it will take to make this the new arrangement from the old arrangement, right? So in old arrangement, the positions of boys were 0, 1, 2, right? And in new positions, I mean the final string, the indices of the boys are 0, 2, and 4. Okay, so how many number of swaps we require to take this arrangement to this arrangement, right? You have to calculate this only basically. So it will be what, 0 minus 0, 0, then take the difference, it will be the 1, and again take the differences, it will be 2. So in total we need the 3 swaps, right? So it is the answer of case 1A, right? And let's just now say see the case 3B, right? When the girls will be in the even indices. And our initial stage was so here. Then it is the another possible arrangement which you can make, right? Which the earlier we see that the boys were in the even indices. Now we are seeing that the girls are in the even indices. So now the question is, how many number of swaps we took to turn this to this, right? How many number of swaps we did? So let us see. We can use the same concept which we have used earlier, that mark the indices. Sorry. right? So here we have to take the boys from the 0 1 2. We can store the indices of earlier we have calculated for the boys, and it is the same cases, but we have to put the girls in the first indices. So we will store the indices of girls here, right? The old indices of girls were the 3 4 and 5, right? And the new indices are old indices. New indices, it is 0 2 and 4, and we have to just take the difference. And why are we are taking difference? Because if we see to transform, to bring to 3 from 3 to 0, the number of operations we require, the 3, the one swap, right? The 3 and b, then the g will be here, and in other swap we will do, then the g will be here, and in another swap the g will be here, right? So in total we require the 3 swap to turn 3 location 3 to location 0, right? It will be the 3. Now similarly the difference will be the 2 and it 1, right? So the total number of swaps we took to make that arrangement will be 6, right? So I hope you understand the approach, you understand the cases which we are having here. So let me just take you the code for code, right? So yeah, here I have written code. So as I have explained that we will take the input, the as the number of the string length, right? The length of the string, the number of the candidates and number of students in the boys, and this is the string which shows the arrangement of the string, right? Whether it is boy boy girl 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 boy 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 girl girl girl. So it will store the string, right? So I have made the two vectors. You can use the array also. For convenience, I use the vector. This will store the indices of boys and girls in the original configuration, right? And I have declared two variables. It will store the count of boys and count of girls, right? So I have just run the loop, right? In each indices, I have checked whether it is B or not. If it is B, then it is boy, and I will push the indices of this in the boys array, right? As the boys is storing the indices of the boys in original configuration, and store the count of boys, right? As I mentioned here, the count of boys will store the count of number of boys in our original configuration or in our class. And similarly with the case of girls, that if it is not boy, then it will definitely a girl, and it will store the indices of girls and count the number of girls, right? Now what we have done here, as I mentioned, the case 1, when the number of boys and number of girls, the difference between them is greater than 1, then the no solution or no arrangement will exist. And if no arrangement will exist, then the solution will be -1, right? Now in case 2, right, what will happen when the number of boys and number of girls are differed by only 1, right? Then in that case, the whosoever will be in the majority, we will put them at the even indices, right? So as I have just same thing I have done here, right? What the indices of 0 is doing here, right? Let me bring back you to that tab. Okay, where it was. Let me yeah. So if we see clearly that if we have number of girls majority, so the final arrangement will look like something like this. In boys, so the indices are what? 0 1 2 3 4 5 6. So the int is storing the first indices of the girl or the boy, whosoever will be in the majority in the final configuration. It will be the 2. If we know the first indices, do we know the next indices also? Yes, we have to just plus the 2 in it, and we will reach those next indices, right? And from here we know the next indices. Yes, we have to just plus the 2. And do we know the next indices? Yes, just 2. Okay, because we know that the difference between the two even indices and two adjacent odd indices is 2, or 2 number, like the difference between 4 and 2 is 2, right? And 1 and 3 is 2. So if we plus the 2 to do anything, it will lead to the next same parity bit, right? So I have done that thing here, that I have taken the indices 0, initial indices of the majority group, right? And I have just calculated the difference, right? The number of swaps we need to take to make that possible arrangements, right? And just increase the indices to +2. Why I'm doing this? This is very much similar to, if someone has confusion, then it is similar to indices. Sorry, indices is equal to indices, the old indices plus I am plusing 2, adding 2 in it, right? And so this will be the condition when the count of girls will be greater than count of boys, and if number of boys will be number of girls, then the same condition will be here, just we have to replace the girls with the boys, right? And in last condition, when the number of boys and number of girls will be equal to one another, then what we have to do, then where there will be two cases, right? As we have just seen, either the girls will be at the edges or the boys will be at the edges. Two conditions. So we have calculated the answer for both of those cases, right? The answer one gonna store the answer for the first case, or you can say case 3A, and the answer 2 gonna store the answer for case 3B, right? And what we have done there, that we have just taken the difference of initial configuration and final configuration, right? And we will compare the whichever will give us the minimum answer, that will be our answer. So this was entire code. Hope I able to explain you the solution. So this was all from my side, and if you have any doubt, then uh, ask in the chat group or in the Discord. Okay, thank you and have a good nice day.